Welcome everyone to join this open seminar hosted by HKUST Library. Also today, it's our great pleasure to have invited Philly from Hong Kong U to give us an open seminar on the topic of open science and reproducible research. So without further ado, I'm going to invite Philly to start the session. But just a reminder that we will have a Q&A session at the very end. And then if you have any questions, also feel free to make use of the chat room to let us know if your questions during the session. So Philly, go ahead. Thank you.
Great. Thank you so much for having me. It's a great pleasure to visit HKUST, even if virtually. One of my most favorite places. I spent many years in HKUST. I did my PhD at HKUST before I went on postdocs in Maastricht in the US, and then finally returned to Hong Kong at HKU. But although I'm at HKU, my heart is still with HKUST. And although I haven't visited in a while because of everything that's been going on, still like the campus and the views of SciKong, it's really hope to get back and visit soon. Today, I'll give you a little bit of background regarding open science and what is called the science reform. I will not go into a lot of details about what is happening in science and what is the science reform. I have many talks about that. But today I'll just focus on what is open science and how you can do open science. Why would you want to do open science? But I really wanted to try and make this practical for you. So there's many other people talking about these topics. So we'll try and do something that's a bit more hands-on. So I'll show you some stuff and I'll talk about my personal journey. Since I started my postdoc, so after graduating at HKUST, I understood that something important is happening. I was an early career researcher. As a postdoc, I had to make some difficult decisions about what it is that I want to do in my career. And I want to show you how you can also do this, whatever stage of the career you're at. Even if you're an undergraduate, then you can do simple things in order to join this science reform movement and endorse open science and practice this in your own projects, in your own domains. Just to say that the slides are available for you to download. So in the spirit of open science, not only the data, code, and materials are shared, but also everything that I teach, all the talks and the workshops, everything is posted publicly. This talk as well is being recorded. So later on, I'll upload this to YouTube and the Open Science Framework. So if you feel like you've missed something and you'll want to go back to it, you have both the slides and later we'll make the video available to all of you. Many of the slides that I'll be sharing are actually not mine. The open science community is a big one. So we help one another. I took many slides from great open science researchers and people who care deeply about this. Many of them are early career researchers and students. So you can see some very interesting presentations like, and applying open science practices to your research, or 5 things that are open and reproducible science that every early career researcher should know. So I love these talks. All of them are terrific. Go and check them out. And I'll just begin with some of my own stuff. Other workshops that I give, so you can see it's not only about open science, but if you work with R Markdown, Jamovi and JASP, alternative open source software solutions, a bit like SPSS, point and click dialog boxes and all that. So there's a workshop on this. We had a big project that we've been doing. Some of this I'll share with you. How to do meta-analysis if you care about meta-analysis. So one of the previous workshops that I did long ago at HKUST involved meta-analysis. So how to do these reproducible in open science, very hands-on and so forth. So welcome to check all of those. And also the talks. So not only the workshops, but also the talks, everything is posted. So there's more of that. This is actually a second lecture that I'm giving on this topic. The previous one I gave at CTU a year ago. You can see the title is very similar, but it had a different focus. So it talked a lot about the issues of why do we need a science reform and what's going on in science right now. So this will build on what was done back then. We'll add a few more stories, but if you attended that workshop, then there's not going to be a lot of overlap. It kind of complements one another. So you can go and watch that if you feel like it. I mentioned some of the wonderful people that have given workshops, similar workshops, on how to ease your way into open science and the selfish reasons to work with open science. So you can go and click on those YouTube videos and learn more from them. I think what's inspiring for me is that most of these folks are early careers. So they're master's, PhD students, some of them recently postdocs and early tenure track. So it's wonderful to see just how the community works together, and that there's more and more posted on YouTube if you want to get to know all of them. Also, some people in my team, I'll introduce what our team is, but for example, Max over here, who's been working with us and publishing with us at HKU, and gave a recent talk at HKU Brown Bag. So if you want to know about our team and our experience as an early career researcher, you can go and have a look at this and some of the other lectures. So for example, the Riots Club and Reproducibility, TEA, where they have tea discussing reproducibility. So these clubs are really terrific. So we have lots of lectures on open science. So I'll start with a bit of a demonstration just to give you an example of what does open science look like. And to me, it's kind of remarkable that I went through my entire PhD not really knowing how to do open science, how to open materials, how to share my data in my code. I had no idea what pre-registration actually is and how to conduct it. So all this I had to teach myself back in 2016. I'll talk a little bit about that later, but I'll start from sharing our team's folder on the open science framework. And if you have the slides, all the slides, the links are over here on the bottom right. So you can also follow this. So open science framework links look like osf.io/something very weird. In this case, 5Z4A8. So I'll open this and I'll show you what that looks like. So if we go over here, hopefully you can see this. This is our core project. So collaborative open research is what our team is called. If you want to know more about that, there's going to be a link at the end. You can see the main contributor is me. You can add additional contributors if you want to, but I'm the one who coordinates all of this. But what you can see already straight off over here is that there are many subcomponents. Each component over here is a different project within the mass replication project that we're doing at core. And you can see different collaborators. So for example, this is Shu-Kit Young, who is working with me on several things. He was an MPhil student who joined me on many replications and meta-analysis. And as you can see over here, it actually shows within each one of these many projects that we have all the components and what they have. So for example, over here, Kit did a great replication and extension of Gilovich and Medvec from 1994. And what you can see over here is that we actually have the data in the code, and there's also the preprint. So if anybody wants to go and access this, let's say it's published somewhere and it's behind a paywall, so you don't need to pay the publisher. This is a pre-edited version of the manuscript that we can share publicly, so anybody can access what it is that we're doing. A pre-registration is basically a plan where we detail everything that we're going to do, from what the survey is going to look like, what are the experimental materials, all the items, the independent variables and the dependent variables, and all sorts of details like a power analysis. How do I know what my sample size is going to be? What kind of an analysis I'm going to run? And so forth and so forth. So for example, if I open this, I can go on each and every one of those. I can see that includes first the component that we shared publicly, so all the data in the code. So you can see over here, there's all sorts of files in here with the dummy data, simulated data, some README that will show you what each and every file is over here. So there's also a SAV, SPSS data file that we load with R. And there's also pre-registration. And the one thing that you can see over here is that the pre-registration is actually linked to as a component, and it says registered on a certain date. So what we do is that we take this plan where we detailed everything with the simulated data and the analysis code, and we put this on a public website, in this case, Open Science Framework. It looks a little bit like that. So it says Open Science Framework Registry. And over here, we have a data stamp. So it says it was registered on April 20. And then I can make sure that the data was collected after the pre-registration was posted publicly. Then it has all sorts of files. So for example, over here, you can see our main manuscript and the replication and extension. So all this is simulation of what the manuscript is going to look like after we collect the data. So we have a plan, we put this publicly, we put a timestamp on it so that reviewers and everybody knows that we pre-registered this before data collection. And only after this is publicly registered do we continue and proceed to do the actual data collection. So you can see that we've done this here. So anybody can go and check our archive. So this is frozen. You cannot change a pre-registration. It's going to be there forever. So people can go and check what it is that you registered versus what it is that you actually conducted. And you can find this for each and every project that we've ever done. So for example, in this project, we had 4 different studies. So all the pre-registrations are, sorry, 5. So all the 5 pre-registrations are available here for you to check. So if you want to know what a pre-registration looks like or how to share data in code, all you need to do is go on this core project, big collection of everything that we've done in a project, and just see how it is that we've done this. And then over here on the right, you can go and visit some of the components of the registrations and examine what this looks like. So for example, in this registration, if you go on the files, you'll see that it froze. This registration is frozen. None, cannot edit this anymore. And go on the archives and then see what it is exactly that we froze. So for example, over here, you can see the Qualtrics survey that we exported, or the actual manuscript, or the simulated data and analysis code in our Markdown. So very detailed. So if you're not sure how to do all these things, then you're very welcome to have a look at that. All right, so going back to this, hopefully this gives you kind of an idea of what Open Science Framework looks like. Let's say that you want to get started with Open Science. How should you go about doing that? And my general suggestion for you is that you start with something called a replication, or replication and extension. So my recommendation is, regardless of where you are, what you do, let's say education, management, psychology, different kinds of psychology, or even in the exact sciences, go and look at the literature, see something that you think is really valuable, that you can easily run. Hopefully something as simple as, like in psychology, we do stuff that is based on scenarios, so vignette style. So in psychology, education, management, and all of that, we're very privileged in that we can run something fairly easily online with Qualtrics. We can do stuff based on scenarios. And I would suggest starting from something with a simple methodology. So I know, for example, I did my PhD in the management department, so they really like complex models, so moderation, mediation, multi-level, and all that. I'm suggesting put this aside, focus on something that has a main effect, perhaps a correlation, or a t-test, perhaps one-way ANOVA, 3 conditions, something like that, or a very, very simple interaction. I'll give you an example of a project coming up soon. Once you decide on this replication, what I suggest is that you write a pre-registration, simulate some data. So for example, we use Qualtrics a lot. So Qualtrics allows you to simulate the data. If you don't have Qualtrics, then there are other ways of very easily simulating some data, and then prepare some data analysis code, whatever it is that you use. Jamovi and R make it very simple for you to do this, but you can also do .sps, kind of syntax mode for SPSS or whatever it is that you use, status, SAS, and all of that. So you prepare this pre-registration, you conduct the pre-registration, then you run the data collection on online labor markets. So we use Amazon Mechanical Turk a lot, or Prolific Academic in different samples from around the world. So very, very simplified tasks. Our typical experiment is between 1 to 3 minutes. I'll show you an example. And then once you ran the data collection, you just update the results section with actually completing the manuscript. So this is what I suggest that you do. Sounds very complicated. It doesn't have to be. So here's an example, a real case study that I completed when I gave a workshop in, I hope I'm pronouncing this correctly, Linköping in Sweden in 2019. And this is how it looked. So I'm in 2019, I'm in Europe. I was attending some conference called SIPS, so Society for Improvement of Psychological Science. And then when I'm there, I get this invitation to go. The conference was in the Netherlands, and this invitation was from Sweden. And I really like this group because they do some really impactful stuff in judgment and decision-making. And they were thinking of conducting a series of replications. And they wanted to know a little bit more about how I run replications with my students. So I was kind of trying to think, what's a good way of us to do a workshop? I can just go and tell them about my project and all of that. But instead of them just listening to my experience, I just thought, how about we just do a pre-registered replication together? So before going, this is what I suggested. You know, within 3 days, I'll come for 3 days before the 26th, on the 26th, on the 27th, on the 28th. Within 3 days, I thought we can do a pre-registered replication and extension. And they were very keen, very enthusiastic about this, and terrific to work with this kind of group. So I was trying to think, how should we do this? So everything that I just suggested to you, I also suggested to them. So starting from a simple vignette scenario study, making all the materials, making sure that all the materials from the original study are available. So that makes it a lot easier because then you can easily replicate this. It was a very simple manipulation, and can be run online with very fast, easy, ethics IRB, because there's no potential harm for participants, and a very simplified methodology. And I had some ideas of which targets we can go for, and this is one of them. Are we all less risky and more skillful than our fellow drivers? And how simple is this? Here's the paper that I selected for this workshop. You can see this is from Acta Psychologica in 1981 from Svensson, and this is the title. So basically it says that on average, as an aggregate, we all believe that we're less risky and better drivers than others. So of course, some of us perhaps not as much, as some people more, some people less, but if you look at the aggregate on the whole distribution, then most of us believe that we're better than others. And driving is a good way to kind of look at this. And you can see, actually, this is the entire method section. So I just actually copy pasted the method section, and this is the entire results section. So the whole paper is 2 pages. And you can see that the entire thing over there is telling people, all drivers are not equally safe drivers, and we want you to compare your own skill to the skills of other people in the experiment, and then asking people, please tell us how, compared to others, do you feel like you're above average, below average? Where do you think you are? If you look at the results are actually, back in 1981, this is publishable. I don't know nowadays if this kind of thing will work, but there's actually no statistics in there. It's all descriptives. So it just shows the distribution of whether people believe that they're better drivers than others. And definitely the conclusion is that they do. Now, you think, okay, simple paper, how is this useful? Who cares about this kind of paper? So turns out that a lot of people care about this very, very simple paper, because if you look at the number of citations, actually it's been cited 2,600 times, which is a very big deal. I think across the domains, if you have this number of citations, it means that a lot of people have been paying attention to this. And I know that when people talk about, in books about the better than average effect, this is the one that is the classic. So you want to target one of these classics from the 1980s, and that is cited a lot, very impactful paper. And surprisingly, not a lot of people, close to zero, have attempted a replication of this. And it's very easy to try and replicate this. So how come we never try to? And the question is, when we try to replicate, will it replicate? It's been around 40 years. So have things changed? Has the distribution shifted? Can we get additional insights? And in addition, perhaps we can use their design in order to say something new about the phenomenon. So what did we do? We pre-registered and ran the study. And finally, within the 3 days that I was over there in Sweden, we were able to conclude a successful replication of the effect. So we got the results, and they were very, very similar 40 years later, very similar to what the original study from 1981 did. Plus, in addition, we added extensions. So we added additional ways of measuring the dependent variable. So we measured robustness, and we wrapped up a preprint. So we really weren't thinking too much about whether we should be submitting this to a journal or not. We just wanted to complete a replication in order to learn something from this, so that this group will know how to conduct replications. We thought of submitting somewhere, but we weren't really sure whether this is publishable or not. I just want to show you, perhaps let me see if I can show you what that looked like. So this is the registration of Svensson 1981 replication and extension. And as you can see, it has the group with Lina and Daniel and the others. And if you look at our files in the pre-registration, so this is frozen. And if you go into the actual files, once again, you can see that we had some R code. We wrote the manuscript. We added the Qualtrics survey in there, and we had some simulated data in code. So for example, if we open the R, you can see that it includes, with some documentation, trying to be as transparent as possible about the data that we're going to collect. What did it look like at the end? So this is the end result of the final data sharing. So all the data sets and the code are shared over here. You can see our preprint over here. For example, we have a README file that shows all the results, which file is what. And as you can see, the main output of our analysis is the Svensson output.pdf, which is basically an R markdown that runs the analysis on the collected data. So basically, you can see one of the nice things about R markdown is that it includes both the code and the outcome, the output, and some additional comments that we have in order to document this, what each line does. So this is just to show that we shared everything. And the main question was, is this publishable? Can we really get this to a publication? So we made all the data in the code public, just like I showed you. We posted the preprint on this Psych archives. So you have preprint servers now. I think especially during the pandemic, it became very popular because we needed fast dissemination of knowledge, not to go through 2 years, 3 years of review life cycle, but we really wanted to get the information out there as fast as possible. Plus, the place we decided to submit to, Metapsychology, forces you to post this as a preprint, and then they invite the entire community to comment on the actual preprint. So I'll try and show you what that looks like. So this is the preprint server. Let me just see if I can open. Oh, I didn't have the actual link. Okay, so this is the preprint server. And on the preprint server, actually you can have different kinds of comments where people have a public comment about different preprints, which is really, really interesting way of doing that. So put everything, so make code available, put this on a public preprint server, so that makes everything open, and then we submit this to an open science leading journal, Meta Psychology, in order to get some peer review. So thank you for submitting the manuscript. So we didn't really know how this is going to work out. What is this Meta Psychology? It's a new journal. And actually, this is the journal that seems to be performing the best on a new factor called the top factor that follows the top guidelines. Top guidelines emphasize open science practices that were created for journals, funders, societies to align scientific ideals with practices, and it provides you a set of tools to guide implementations of better, more transparent research. So you can see that they have different levels. So for example, do journals, editors, insist on data transparency? Do you have to share the data in the code? Do you have to do a pre-registration? Do you publish replications and so forth? And the reason why we went for meta psychology is that you can see that actually you have level 1, level 2, level 3, and level 3 is the strictest or the most open of all the standards. And as you can see, meta psychology does really well. So level 3 on almost each and every one of these, aside from perhaps less strict on some aspect, but most of these are 3. And if you look over here about the journals who are leading these impact factor sort of transparency ratings, meta psychology is currently the highest one with 27, followed by some other fairly new initiatives like the peer community and register reports, and this journal that only publishes register reports called Comprehensive Results in Social Psychology. So really, meta psychology is revolutionizing a lot of things in our field. So we thought it's appropriate to send the replications with the data transparency, with the pre-registrations to that journal. The end result is that this was conditionally accepted at Meta Psychology a couple of months ago. So this is January, and this is what Ricard wrote over here. I'm happy to conditionally accept your paper, and then all of that. So the nice thing about this is that anybody can see the entire review process. So you can see everything that's currently under review in Meta Psychology if you go on this link over here. And I'll give you an example from another publication that we have at Meta Psychology. So this is one that I did with Ignazio, who is an early career researcher that's currently based in France, who joined our team in order to publish one of our replications. And this was, I think, our first submission to Meta Psychology. And what's remarkable about this is that if you click on this link over here, let me see, where was this? Yeah, so if we click on this and open this together, you'll see that this is what the journal did. I did not do this. So you can see that Ricard, the editor, is the person who did this. And Lucia, I think, is the person who did the reproducibility check. So they make sure that everything that you submitted, including the data and the code, seem to be in support of what it is that you actually reported. And as you can see over here, there's 2 samples. So they link to the pre-registration. They have the preprint, the data material, and the code. Plus, and this is remarkable because I don't know any other journals that do this, they also share the review process. So you can see all the comments by all the reviewers, the decision letter, the first one that we got, the revision, and then finally, the end decision letter that says that this is accepted for publication. So very, very high transparency. This is a revolution in the way that journals operate. So you as a reviewer in meta psychology can get some credit for your reviews. It's not hidden, it's not anonymous, it's not going to be forgotten, but you can actually link to this DOI and show that you've reviewed, that you've contributed, and really all the reviews that we received in meta psychology so far have been very positive and constructive, really helping us improve and bring the papers to a new level. So as you can see over here, everything is shared and everything is very well organized, and they have this for each and every project in meta psychology. One interesting thing I just wanted to show is that this is the PDF of the actual manuscript. They have badges, so you can see that it's pre-registered, it has all the open data and the code. It links to this open science framework. And importantly, these are HKU undergraduate students. So you can count how many. So there's 2 from advanced social psychology and 6 from fundamentals of social psychology. So this is just to show that in my courses, all the courses that I teach undergraduates at the University of Hong Kong from second year, fundamentals of social psychology, to advanced social psychology, 4th year, are my collaborators, my co-authors. In the semester, during one semester, 3 months, we complete a replication and extension of a classic effect. This, for example, was perceived morality of direct versus indirect harm, so the preference for indirect harm effect. And what you can see is that everybody gets credit. And the credit between the first author, so Ignazio over here, and our students is shared. So this is the one over here. So they're all shared first co-author. These over here are my teaching assistants. So they, of course, helped to guide the students. So they get credit. And then me trailing over there at the end. But this is to show that during one semester, the students complete a pre-registered replication and extension. So if undergraduates can do this within one semester, you can as well. And after that, I go to the community, I invite people, early career researchers like Ignazio, who is an assistant professor, and then they verify everything that the students did. They combine the reports, they add some analysis, they make the introduction and the discussion stronger, and then we submit this together to journals like we did here to Meta Psychology. And as you can see, finally it gets published. So the students get publication, Ignazio gets publication, and the entire community benefits from this because now it's has been peer reviewed, all the peer reviews are public, all the data, the code are public. So this is really a collaboration, a team that works together in order to get an important effect in the literature replicated and then disseminated, refreshed in the literature. So what do we gain from this case study and the final one with Ignazio and the students is that my suggestion to you is start simple, very, very simple. Do one open science pre-registered replication, choose one classic, many classics that are very simple to do in the literature. You can complete this replication within a few days. Practice your pre-registrations. At the beginning, it's going to be a little bit difficult, but there's lots of templates and lots of tools. And now we have a lot of examples. So you can take this from us. It's a bit intimidating, publishing, posting all the materials, the data, and the code, but there's very good reasons why you would want to do this. And at the beginning, it's difficult because you're not really sure how to make this reproducible so other people can really check and visit what it is that you did. But if you submit to a journal like Meta Psychology, they help you check this. And if something is wrong and it doesn't reproduce, then they will tell you, please improve this, please improve that. Then post this as a preprint. So even without the publication, just by the fact that this is posted as a preprint, you will get a DOI. You can cite this, other people can cite this, you can put this on your CV. And then if you submit this to an open science supportive journal like Meta Psychology, then you have amazing benefits like getting good expert constructive feedback from the reviewers, and then just by the process of meta psychology, ensuring that everything is open, transparent, and up to the highest standards of open science. So you've got the team, you've got your own work with the templates, with the pre-registrations, and then you've got the infrastructure in preprints and meta psychology as an open science supportive journal. Another thing to think about is like if you want to, it's helpful to find a good mentor or a good team. So just like I found those in Sweden, and just like the students found me in my courses, or Ignazio found us on Twitter and through a conference, you can also find others and form some collaborations with them. So yeah, just find somebody with some experience, or a team that you would like to work with. So just a short note on how I got started with open science. So I wasn't always doing open science, and unfortunately at HKUST during my PhD, I didn't know very much about open science and what that means. So I'll tell you a little bit about how I made progress with this. So I won't go too much into the issues of why we understood that we need open science, but in 2015, 2016, there were very disturbing signs in psychology that we need to change the way that we do science. So in 2016, I started my postdoc at Maastricht University, and they gave me a lot of freedom and flexibility to decide my own path. So I sat with myself for about a year and decided, okay, I'm going to put everything that I've done aside, and I'm going to rethink what it is that I want my career to look like. So what are my goals as an early career researcher? And I decided that above everything, I emphasize trustworthiness, reproducibility, and replicability. Now, it might seem to some of you like this is taken for granted, but it's really not, because the way that I've been trained has always been on novelty, on theoretical contribution, on how I advance the literature forward, on how I create these novel ideas, how I find things that are somewhat counterintuitive in order that I can market and sell this and get this published and build a career, a reputation around being an innovative kind of researcher. But I understood that there's a price to pay, especially given that everybody is pushed in this direction. And sometimes it doesn't go well with, solid, careful, slow work that emphasizes that you want your findings to be trustworthy. You want everything to be able to reproduce well. And if others will be executing a similar study, that it will be replicable. And a few basic components here I did not know how to do. So I didn't know how to do full transparency. And it's not just about sharing all the materials, data in the code, like I showed you on the Open Science Framework, but it's really sharing everything about the process, including, if you ran some pre-tests or if you ran some experiments and they didn't work out, to share those as well. We need to learn and we need to share more about our failures, not just about success. Survivor bias is a very strong bias. So we look at these amazing success stories and we say, if we only follow their path, then we're going to be as successful as they are. But we don't see for every one success story all the failures of people who tried similar things and failed. And we need to get some understanding of, is this a special case, or is this the only case? If I follow them, it will guarantee success. Plus, we don't really document a lot of decisions like exclusions of conditions or variables, all kinds of decisions about how do I do outlier, taking them out of my data set. So a lot of decisions that we do in the research process, we're not really completely transparent about those. And sometimes we briefly talk about those in the papers if we do that, but we don't explain what's behind it, or we don't allow others to really check what it is that we mean. So that to me was that science is more like a trust system rather than us being really open and transparent about everything. So at least I decided that for me in my own research, I want to try and live up to these standards. This is a long-term goal. This is where I'm aiming. Another thing is that I used to work with myself most of the time, or maybe with my advisor, and I understood that this is not this is not a good way of working. So I decided, as difficult as it is for me to collaborate with others, and as much as I like control and certainty, collaboration and community is very, very important. So I'm going to try and build as much of that as possible. And I've been really stretching myself in order to get a group of people together, even though this is not my personal inclination, more introverted and more, me with myself and being able to plan things. When you involve a lot of people, you have different preferences, different people pulling in different directions. So I needed to learn how to collaborate with others and how to work as a community. I decided that I'm going to do a lot more pre-registrations and register reports, and I'm going to talk a little bit about that. And I know it's not appreciated in the literature, but I decided rather than novelty and doing new things all the time. I need to see what's solid, so I'm going to do a lot more replications. And then all the other things that we talked about, preprints and null findings and such. So in 2017, decided I am going to change the way that I work. I was a little bit scared and hesitant of trying these things on my own. Plus, I had a lot of other engagements. And whenever I talked to senior scholars and I told them I really want to try and do replications, I really want to do pre-registrations, they were absolutely not. We've been working on science for 40 years now. We've never done these things. There's no reason to start now. So I understood that the way for me to start with this is by me working with students. So I told all the master students, we were supposed to take in 3 or 4 thesis students, even as a postdoc. So I told the students, I will only work with you if you're willing to do a pre-registered replication and extension with me or a pre-registered meta-analysis. And it's amazing because usually they give a preference of 1, 2, and 3. Is that almost nobody wanted to work with me, which is kind of made me feel bad. But the 3, 4 students that did want to work with me on pre-registered replications and doing open science put me as the first priority, which is, so they really wanted to try this out without really knowing what this means for them and their thesis. And when they asked me, so can you tell us, how do we do this pre-registered replication? I told them, honestly, I have no clue. This is the first time that I'm trying this. So I invited them to join me on a journey where we both try and figure this out together. So working with a student, thesis student, master student on a project is a good way to train yourself and get started. So the first brave soul was Lucas over here. So Lucas came to the first lab session, said, okay, I'm ready to do a thesis. So how do we do this pre-registered replication? He said, I don't know. I said, okay, but let's say that we do this pre-registered replication. Is anybody going to be interested? And I said, I honestly don't know. I've never done this before, and I can't see any published replications in the literature. But how about you go on ResearchGate, which is kind of like a Facebook for scientists, and just write that we intend to do this. So Lucas went on, this is a screen capture from February 2017. The aim of this project, before we did anything, we didn't even have a plan, aside that we wanted to do this. So the aim of this project is to conduct a pre-registered replication and a meta-analysis on this classic effect. And to our surprise, a month later, so this was February 2017, in March 2017, Sander Kool from the Free University of Amsterdam, who was the incoming editor at Cognition and Emotion, wrote to us as a reply to, Dear Lucas and Gilad, ResearchGate, we are seeking to publish more pre-registered research. Please consider Cognition and Emotion as an outlet for this project. So Lucas was just amazed and very thrilled and said, this is amazing. We're going to publish the thesis as a publication in Cognition and Emotion, which is considered very reputable in psychology, cognitive psychology and emotion. And I told him, calm down, there's a long way to go. We haven't really done anything. And just by the fact that somebody comments on ResearchGate doesn't really mean that they're, when we submit, that the reviewers are going to be enthusiastic and this is going to work out. That's a very long journey. But finally, remarkable, Lucas did a very, very good job with this replication, and we did submit this to Cognition and Emotion, and it did get published at the end. So from being worried about can replications and extensions be published, this is the first time that I tried learning with Lucas together on how to conduct a replication extension, posting everything publicly. So this is the essence of open science. Communicate to others what you're going to do, even if you haven't done it yet. Then get the community to react back to you. So for example, here, Cognition and Emotion was very interested in more replications. And then finally, as a community, it might take some time, but at the end, we were able to bring this to a publication. It's not only Lucas. I had 2 other students. So Tijen also did this, and Yajin Gao also did this. And with them as well, Sander Kool just kept asking them questions. Would you consider publishing this? in cognition and emotion. So finally, these two were published in a different journal because we wanted to try other things, but all of them got some very serious interest in their work, which is amazing. So can you imagine this, a master's student in a one-year thesis who didn't know anything about open science and privileged replications, finally getting, not once, Lucas has 3 publications from his master's thesis, just because I think everything was open. So one is a replication, one is a meta-analysis, and one is a review. Terrific for Lucas. And for me, this really showed we can do stuff with open science. So it's not just me sacrificing my career and therefore never going to publish anything again. But as long as I'm open and I'm transparent and I invite other people on this journey and I try to communicate as openly as possible, then there will be interest. Then good things will happen. And I think throughout my very short career, I saw this happening again and again. So at this point, where are we? Okay, 45 minutes in, you must be thinking, okay, it's very nice that you were able to do all these things, but can we do this? We're not really sure about our ability to do these kinds of things. And my message to you is that, yes, you can. How to get started. So by now, after 4 years of being at University of Hong Kong, one of the main contributions that I think our team has had is that we've built a lot of guides and templates, and we have tons of examples on how you can implement this in your own work. So you don't have to start from scratch like I did in 2017. Now we have a whole community of people who are contributing to others, helping them. So you can take any one of our many resources and then use this in your own research. So I'll just open this as an example, and you'll get to see a little bit of my website. So if you go on this link, so this is my website. There's lots of stuff that you can check about open science, about how to do a meta-analysis, about our mass replication and extension project over here. But I think the most important thing for you to get started is to follow any one of those. So we have how to use Jamovi and JASP, how to do RR Markdown, how to run a replication and extension, a very comprehensive guide, how to calculate effect sizes, how to confidence intervals, how to do a power analysis, some statistics and methods, best practices, how to use Qualtrics, how to use mTurk and Prolific. So a lot of resources that you can go and use. One of the nice things about open science community is that if you want to contribute, let's say that you see something on this guide that you think can be improved. If you go on this guide and you contribute, so all of this is Google Docs. Anybody can go in and edit any one of these things. If you put your name and mention what it is that you contributed, when we submit these to journals, and we aim to submit most of these to journals, you become a collaborator. You're a co-author. So everything is collaborative. Everything is open. If I would have to write these guides by myself, it would never be very, very meaningful. It would not have a lot of information. But some of these templates are very, very long, about 60 pages. So if we, for example, I don't know, like the RR Markdown, if we open this, then we'll see tons of resources. And I don't keep this updated by myself. A lot of people in the community contribute to this. So you can add your name over here as a contributor, say what it is that you've done. And you can see that everything is a Google Doc. So you can go, you can add some stuff. And if you've added some stuff, just add your name. And when we submit this, you get a publication. When it becomes a preprint, you have a DOI and you can cite this. So this is perhaps just a series of links, but many of the other things that we have are a lot more hands-on guides that can be in the form of a publication or a submission. So lots of resources over there with code that you can come take in and adapt. So a lot of these resources are available to you. Plus, as I mentioned, if you don't know how to do a register replication extension, we have a guide for this as well. This is what my students use when they're doing the undergraduate course with me. So for example, here you can see, so how do we do this? What is the process? I'll get to this very soon. What are the deliverables? So what do they need to do in each and every section? How to do this with some links on, how to export stuff from Qualtrics, how to simulate data, how to write the tables for the design, how to do interactions, what to do with the data analysis plan, what does the manuscript need to look like. So very detailed. Just go and have a look at this and see how this can contribute. Also some guides on APA style, how to write hypothesis. As you can see, for example, Katie, who is the teaching assistant helping me last semester, came in and added some stuff. So together as a community, suddenly, instead of 1-2 pages that I can write on my spare time, this becomes a community effort, and everybody can go and benefit from that. So this is the first thing that you can do in order to get started. If you want to see, for example, something like a pre-registration, then I have a lot of examples on how to do these kinds of things. So I conducted a live demonstration. So do go on this talk and see how I do this live with the audience. And so we pre-register together. Then I run a survey on the audience of the talk, and then we analyze our responses together. And it's amazing because we were able to replicate something that's called the default effect live. So you can even do this within a one-session workshop. So that's one opportunity for you. Now, let's say that you're a bit scared of this and you want to gain some experience by working with a team. So what teams are available to you? And I would strongly encourage you to do both. Try things on your own, but definitely join one of these amazing teams that are working right now. And I'll mention 3 of those, although there are many others that I don't have the time to cover. Join an open science collaborative community to do some remarkable things together. So one of the biggest revolutions, I think, in psychology in the last decade is the Psychological Science Accelerator. So why do only physicists work together in Switzerland, in CERN? Why don't we know how to work together as psychologists? So early career researchers came together and said, maybe we can build something like this for psychology. So you can see over here that it has a lot of psychological science labs from around the world with 1,328 members, representing 84 countries from 6 continents. And this is the main publication that announced the Psychological Science Accelerator to the world in 2018. And you can see what these collaborations look like. So a very long list of many of them early career researcher folks who are dedicated to open science. I know a lot of these names. I follow them on Twitter. I see their talks. Really remarkable people. Some people also from our team. So for example, we've worked at the University of Hong Kong with Cameron and a few others over here. But most of these names I have corresponded, worked with, met personally, especially around the Society of Improvement of Psychological Science. And they do some remarkable stuff. So they announce what projects they're going to do. And you can contribute by doing a data collection or reviewing a manuscript, or there's a bunch of phases that they have, and this is detailed here. You can go and look at the actual manuscript. And any contribution leads to co-authorship. So you can be one of the many co-authors. Now, I did not intend this, but one of the side effect benefits of this, first of all, I wanted to be part of this community. So I decided whenever I can, I'm going to collect data for Psychological Science Accelerator. I want to be one of these many laboratories from around the world. We need a representation here at the University of Hong Kong and Asia. But the unintended benefit of that is that my department really cares about impact factors and high reputation publications and all of that. And for me, this is not a big deal. I really don't care about this as much. But every year they ask me, so have you published in Science? Have you published in Nature? Have you published in PNAS? And honestly, up until 2 years ago, I told them I'm just not interested. This is not my competition and my race. I stayed out of it, but unexpectedly, just because I took part in the Psychological Science Accelerator, it's it's only March in 2022, but I already have 3 publications with the Psychological Science Accelerator who published in Nature Human Behavior, who published in PNAS. So I'm not a lead author. Only thing I did is data collection, but I'm recognized, I'm acknowledged as a contributor, therefore I get co-authorship. It's not only this, but it's going to keep coming because there's a bunch of register reports. So register reports is where you submit your plan, you submit your pre-registration to the journal, and the journal gives you an in-principle acceptance. It means that it doesn't matter what the results are, this is going to be published at the end. So I already know that these projects are going to be published at Nature Human Behavior, at Advancing Methods and Practices in Psychological Science in 2022 or 2023. And many of them are very important projects, like how to respond to COVID-19 pandemic. So they've done some remarkable work during this pandemic in order to try and do something in psychology to address, help society in some way to understand interventions on, how can we aid, what is our contribution during times like this. So I didn't really do very much aside from collecting some data and reviewing some manuscripts, contributing here and there. But because of this collaboration, everybody is acknowledged. Plus, I learned tons from this because I see how other labs are doing the work. I see this massive collaboration. It's really revolutionized the way that I think about science. And this is what science should be. We should be working together. We should be, helping one another and then getting impact. Okay, so this is in terms of the Psychological Science Accelerator. You also have CREP, is the Collaborative Replication and Education Project. And this is a great group of people that actually want you to work with undergraduates. So they suggest a project for replication, and then any labs with undergraduate students can do this replication work. You can sign up for one of theirs, and then finally they submit this to a journal. They put this together. So you can read about this in these 2 publications that they had. And this is a very impactful open science community. Folks, many of them who I've met or I know personally. So I love this. And I've learned a lot from this for my own team and my own projects. So I really recommend that if you are an undergraduate or you're working with an undergraduate, you want to try open science and replications, go and look at CREP, learn from them, join them, see how you can benefit from their work process. And one of the favorites that I have from the last 2 years is this the Framework for Open and Reproducible Research Training. They do some remarkable things. So I really believe in the many things that they do. So they try and share as much as possible, aiming at kind of education, but collaborative resources to try and promote the field. So for example, they document all the reversals and the replications that have been done. So somebody needs to keep track of this. Somebody needs to keep track of all the educational resources that are available over there. And most recently, this glossary initiative was published, can't remember where, but one of the impactful journals out there. And it just goes to show that within 1 month or 2 months, they were able to have a Google Doc of hundreds of pages, hundreds of people contributing and editing one another, and within no time, they were able to get some very high quality manuscript written, submitted, and an important resource. And now they're working on this glossary initiative 2.0. So I see great things ahead for this 4th initiative, and I know how passionate the folks in the lead are over these things. They're underfunded, which is a shame. Hopefully there'll be some more money coming into all of these. Psychological Science Accelerator has been struggling to get funding for a very long time, but just by the fact that everybody comes in and contributes without really expecting much in return is already leading to some very impactful end results. I'll talk very briefly about our team and what open science is for me, for us at the University of Hong Kong. What's our team like? So I never imagined to be, coordinating or kind of arranging this kind of collaboration. As I said, I used to work on my own, but after 4 years, we have around 75 early career researchers, around 20, 30 of them are lead authors. You can see some of the countries that they're from, some from everywhere, mainland China, Hong Kong, Taiwan, this region, all the way to South America, Brazil, of course, the Western countries of Europe and North America, but slowly expanding to also other territories, a few from Australia, New Zealand. So it's nice to see in the Middle East. It's nice to see these things growing slowly. I never imagined. I don't invite anybody personally. Most of the time, I just go on Twitter and said, "This is what we're doing. Anybody wants to join?" And it's amazing that although nobody really knows me, who I am, I'm just some nobody from University of Hong Kong in the middle of nowhere. They want to join. They want to get to know what it is that we're doing. By now, I've guided about 36 thesis students on replications and extensions, plus all of the folks, students that went through my courses, undergraduate students, completed replications and extensions. So we're talking about 370 of those. What is the process that we typically do, that I do with my students? So the first 2 years we did with data collection. I funded this from my own seed money at University of Hong Kong. So just like I showed you, the students do the Qualtrics survey, they simulate some data, they do some data analysis on the simulated data, they write the pre-registration. Typically what we have for every replication target, we have 2 teams of 2 students working independently, and then they peer review one another. So they learn by themselves, and then they get to review the other person's work and then see some of the differences. Also, every time they submit something, I go on Twitter and said, my students did something. And because everything that they do is on open, on Google Docs, then anybody on Twitter can come in and give them some feedback. And it's remarkable to see that some of the community is really helping them. Undergraduate students from Hong Kong are getting feedback by some top researchers from around the world, some great feedback from the open science community and early career researchers. So really inspiring to see. And I think it blows the minds of undergraduate students that some of the stuff that they do in the classroom is practical and people are interested and they get feedback from the entire community rather than working by themselves about something that is thrown to the file drawer or gets forgotten at the end of the course. So they get some feedback, and then they submit a revision. Then I go and I pre-register this on the Open Science Framework. I collect the data for them using my seed money on the Amazon Mechanical Turk or Prolific Academic. And then I give them the data sets. They work on this independently, and then they peer review one another. They do a joint presentation in the class. I invite the Twitter folks to do this, and then they revised. The interesting thing about this is that at the beginning, I just thought, okay, we'll do some projects at University of Hong Kong, and then I'll just put this aside. I'll post this on the Open Science Framework. But I never thought that we'll be able to publish any of these. But at some point in 2018, I decided I'm going to offer anybody from around the world to come in and take the lead over these projects. So they'll be joint first author together with the students. So we give them everything. We give them the early career researchers. We give them the data sets, the manuscripts that students wrote. And here at the end, as you can see over here, the revised final report is an APA-style submission-ready manuscript. And what the early career researchers do, they come in, they verify everything that the students did, they add their own analysis, they make the introduction and the discussion stronger and solid for submission. And then finally, all of us as co-authors, we send this to the journal to get some feedback. So this is what we did the first 2 years. I'll show you what the end result was for this. In the last 2 years, we've focused mostly on register report stage 1. So I don't do the data collection. The students focus on doing a register report. So making sure that the pre-registration plan is the best that it can be. And we submit that plan to the journal. So to get some feedback before we do the data collection. And only when the journal says, we accept this for publication. Only then we proceed to do the data collection, which is a completely new model, and I'll come back to this later. So this is a register report. So this is what we've been doing so far. So after 4 years, how many of these have I done with students in my courses and thesis students? We've done 120 of these, which is quite remarkable. So 80 with data completed, and about 40 that are register report stage 1. And if you want to see some of those, you're very welcome, because we share everything and everything is open. So if you want to learn from the students at HKU, you're very welcome to just like click on these links, and you'll see how it's organized. So for example, this is from 2019. So this includes data collection. And if you open this, you'll see that for every replication targets, there are 2 groups of 2 students who do this, and we conduct the data collection with 2 different samples. One of them is M-Turk Americans and Brits on prolific academic. And you can see the sample sizes, they're quite large. So these are very well powered samples. You can see the pre-registration, so you can follow any of these links to see all of that. And you can go and see the final reports. So at the end of the semester, it's quite remarkable to see that, you know, the group here in Heyman and Ariely did 2,200 participants, and everything is available because open science and all that. You can see all the raw data, you can see all the code, everything that they've done, and you can also read the actual manuscript that they wrote. So how good is this? You can see it looks like a manuscript. It's actually, it's built exactly like a manuscript. So if you look at this, it has an abstract, it has, you know, everything like an introduction, and very well written. So, you know, summary of all the hypotheses. And these are undergraduates. So if the undergraduates following our templates are able to deliver this kind of thing, including the method section and some analyses, we'll get to the results section. So this is very comprehensive, and they're able to do this within a 1 semester course at the University of Hong Kong. And at the end, this specific one, Heyman and Ariely, we just published this in Collabora Psychology. So finally, their 1 semester course at University of Hong Kong led to a publication that they can use in their CVs. And this also helps them in industry, or especially if they want to go to an academic career. So you can visit any of these and have a look at what our students are doing. If you want to see what a register report looked like, you can link, you know, click on any of these other links from 2020 or 2021. What is the end result of this? If you look at, I never imagined, this is, you know, when I started this 4 years ago, I had no idea that this is what's going to happen. But what you can see over here is that in 2021, which is a very difficult year for Hong Kong and the world in general, pandemic and all that, our team was able to deliver with 15 different publications. All of the people who are, you know, with an underline are students, early career researchers are first authors, and you can see the star means that it's shared first co-author, and then followed by the teaching assistants, and then finally me at the end. And you'll see that we were able to get this into all kinds of different journals in psychology. So experimental social psychology, some of this is economics journals, judgment and decision-making, meta-psychology was very receptive, you know, very reputable journals like Social Psychological and Personality Science. And it just keeps on going. So we're just only in March 2022. There's a lot going on, but this team works so well together that they're able to keep pushing this regardless of the very bad situation worldwide and the pandemic, really going strong, because we have all these, you know, layers, checks and balances. First, there's the course, then there's the early career researchers, then we put the preprint, then we invite a Twitter community, then we have the journals and the reviews. So all these checks and balances finally lead to what I believe are very strong, solid submissions. And of course, everything is shared. So if you want to read any of those, you can go on the Open Science Framework or read those. And also ongoing right now, we have a lot of register reports. So all of the thesis students who are working with me, all the theses are submitted to journals. So we submitted 2 last week, 1 this week, there's another one coming up, and 6 more coming up in the following months. And you can see some of them are right now. We'll get some feedback. So the team is very, very productive. Everybody works very well together. And even with my students, if I'm able to do this with students during one semester or one academic year, you can as well. Now, it's not, probably doesn't mean a lot coming from me because, I have, I'm very involved in this and have a lot of experience, but what does it look like from the student perspective? So you don't have to listen to me talk about this. You can actually listen to the students. So Nadia over here recently gave a talk at Brownbag at HKU talking about her experience as an undergraduate thesis student. She was also in my courses. So she first was in the course and then wanted to do the thesis with me. And she was able to publish both. So just last week, she published the default effect, which is what she did for her course. And then previously, earlier this year, she published her thesis project, which is remarkable. So you can listen to her talk about this and the stuff that she gained. Cora is a master's student, so she was able to deliver on that. And not only do we have YouTube videos where you can see their talks, but also we have a Psychology Today column, so you can go and read about the student perspective. And if you want to hear a little bit more also from the early career researcher perspective, the ECRs, so Jian Chen is also a HKUST graduate. She did her, we were in the same department together at management in the business school. She's now a professor in Manitoba in Canada. She led one of the collaborations which finally got accepted to the journal. More recently, we've had Max and Hero. Both of them, have a Psychology Today column. Max also gave the talk, so it's available on YouTube. So they took the projects from our students at HKU and were able to bring this to a publication. So it's remarkable to see all of this happening. Adrian is one of our more active early career researchers, so you can go and listen to his testimonials. So you can just see how productive he is by joining us on this team. We don't have time for me to discuss too much of what it is that they've done, but I try to summarize this for you. Not from my perspective, but from the students' perspective, from the early career researchers. Their main message is, you as a student, you as an early career researcher, you have the power. You don't need a senior researcher, you don't need your PI, you don't need to wait for a professor to give you some resources and lab money or their time. You can work as one of these, a member of one of these teams in order to start your own open science collaboration, and then many of these end up being published. The best way to do open science is just get started with open science. So just do something hands-on. Don't be scared. Join one of these. You can join one of us, where one of our projects where we already have some of this completed, so you can see what the students have done, what the early career researchers have done. And I think once you start working on things, you'll realize that open science is much easier than you think. It's just a matter of forming good habits. And the more that you do, the easier it's going to get over time. It's just a matter of you having the courage to take the next step and do things in an open science way. Small steps make a big difference. So it's not like you have to endorse everything. You don't need to start, from nothing to everything in one project. You can do small steps. So you can say, first I want to do a pre-registration, or first I want to do data sharing, or first I want to do a replication, and then in the next one I'll implement something else. But just like scale this for yourself, so you know what small step you're making, and you'll realize that every small step is actually a big difference. It makes a big contribution. Plus, I think conducting open science, I've learned, leads to higher visibility, for good and bad. I've had some negative responses to some of the stuff that I do, mostly from senior researchers. But overall, my visibility is very high, both on Twitter and in terms of the impact of the team's work. So it adds to your reputation. So wherever I am in the world, or whatever it is that I'm doing, I get invitations to talk. Jennifer here at HKUST contacted me. I don't think she even knew, or maybe she did, that I'm an HKUST graduate, but just reaching out to me and asking me, can you come and talk about these things? So doing open science, because everything is open, transparent, then it leads to more people wanting to work with you, and more collaborations, and more impact on science overall. Generally, I would emphasize community and collaborations, and everything, because it's open, it gets a lot more. So if you want to hear more about our team, I gave a 3-hour version over here and a 40-minute version over here, and you can get more feedback on this. I think at this point, I wanted to say some stuff about open science, but I'm going to skip this from now, especially given that I already did a workshop on registered reports last week, so you can go and listen to that. But there are more stuff about registered report over here. I'm going to skip this. If you want some demonstrations of registered reports from last week by my undergraduate thesis students that are working together with me, you can go and click on these links. There's some feedback and advance. I'm going to just run through these. And I just want to say that if you want to try registered reports, then we have some templates, we have some guides, and we have a lot of examples. So you can join us on any of these. If you want, the main link on how to join us is this one. Just click on this. It's a Google Doc of about 20, 30 pages, details all the possibilities of joining our team. You can also check out the Psychological Science Accelerator and others. But everything that I mentioned, all the the videos, the resources, the links, our team, everything is on this one main link. So you can scan the barcode or click on this, and you'll be able to find more information about all of that. You've seen my website, so you can click on this and get some more information. I'm very active on Twitter, so you're welcome to follow me on Twitter over here. We have a mailing list, so if you want to know more about upcoming talks, so there's one, I think, in University of Vienna coming up. After one, there's one in Oslo, one in Bergen. So almost every week in the upcoming months, I have a talk that is about different topics. So for example, next one in Vienna is going to be, it's called Check Me, Replicate Me, about why it's important for inviting others to attack, to do red teams on our own research, and why corrections and self-checks are very important. So all this is available to you. Welcome to contact me in any one of these avenues. If you want something a bit more personal, this is my email. I try to be very responsive. So just let me know how I and my team can help you do good open science research. Many opportunities for us to work together. So hopefully this gives you a basic understanding of what open science is and the possibilities of you doing open science as an early career researcher. So that's it for now. I'm open for questions if anybody wants to talk about something or ask some questions. Thank you.
Well, thank you so much, Gilad. Yeah, it's very inspiring and thought-provoking. Thank you. We have some questions in the chat box. The first one actually is from Edith, sent to us like 1 hour ago. So maybe Gilad, you can scroll up a little bit to see the question. Yeah. And then, but if you have any other question, feel free to put it down to the chat box, and then we will go through them. So Gilad, can you see it? Or maybe I can read it.
It's okay. I'll ask, what does it mean for, when you do a pre-registration, does it only work for a new project with new data collection, or can you do a pre-registration for an existing data set? So yes, you can use pre-registration as a tool for existing data sets. There are different levels of, so let's say it this way. As long as you're completely transparent about what it is that you've done and what it is that you're going to do in the future, and you differentiate between these two, then you're good. And then the question is, what inferences can you draw from that? So if you've already had a data set and you've analyzed this many, many times, then you need to be transparent about that, and you need to make sure that the pre-registration is, you can't post hoc pre-register something that you've already done, that the pre-registration really talks about something that you haven't done yet. Also, you want to try and reassure the reviewers that that the pre-registration is really confirmatory, so that you've had some hypothesis in advance, and then you're using the data set in order to test something, test your hypothesis with data that you haven't seen yet. So I'll take an example for an existing data set. So let's say that you have a very large data set and you want to combine exploratory and confirmatory. One of the things that you can do, for example, is you can randomly split the data set. You can pre-register this. You can split this into two and then use half in order to run as many explorations as you want, and then use the second half randomly decided the second half of the data set in order to test what it is that you found in the exploratory part. So this is the way that you ensure that you have both exploratory and confirmatory. Another way to do this is, for example, saying if this is a data archive that already exists, but you don't have access, then you can say, once I have access to this data set, then I'm going to run these kinds of analysis. So just be transparent about what access you have, what analysis you've conducted, how you're differentiating the exploratory from the confirmatory, and then you just adjust the way that you draw inferences from that. So if it's exploratory, it just means that you will need to rerun this again with another data set in order to confirm the hypothesis. If you can use the same data set, like you haven't seen this data set before, you haven't analyzed it in a certain way, just be transparent about this. Pre-registration is not meant so much for fraud, so you can always cheat the system. There's all kinds of ways of trying to fool everybody, but it's not meant for that. It's just meant for you as a tool to kind of differentiate, where you are, what you hypothesize. You don't want to fool yourself, and you want to be as transparent as possible to the world about what your plans were, what you did, and what your inferences are in accordance with that. So hopefully that answers that question. Gabby has something here: to make research transparent, like sharing your process and decisions, you're making yourself vulnerable. How do you handle that? So it depends how you look at vulnerable. Actually, my view has shifted completely on this. I think the thing so in my PhD, I used to be very, very scared of people finding mistakes or seeing that I'm stupid or silly. And I realized that actually by hiding what it is that I do, I'm actually hurting myself. Because can you just imagine for a second that you had a mistake in your article, and you wrote this article and you published this article and you have hundreds of citations, and a lot of people have tried to build on this. So they've invested millions, and a lot of groups have tried to build on what it is that you've done, but they can't seem to replicate this, and they can't seem to build on this. And they can't get this published because replications are not published, but you get the reputation. So more and more citations, more and more people investing money. And then after 20 years comes out this statistical method that actually shows that you have an error in your manuscript. And then you realize the amount of money, the number of people who have invested their lives and ruined careers trying to follow a mistake that you had. Can you imagine, just like at the end of the career, instead of just saying I've contributed something, you have this regret, burden, guilt of I've done a mistake and I didn't catch this on time. And this is when I realized that actually transparency does not make you vulnerable. It makes you a lot stronger. And this is the talk that I'm going to give at University of Vienna. That's my next talk. Is that I actually, if you go on my website, there's a section called Check Me, Replicate Me. It's not only that I share my materials, my data, and my code, but I will pay you money. If you go and find a mistake in my research, a big mistake, I will pay you $50, a small mistake, $5. I want you to help me catch mistakes. The way for me to not be vulnerable is not by hiding everybody and just pretending like I've never made mistakes. To be strong and to overcome being vulnerable is to share everything as much as possible and ask other people to help you, to attack you, to find all these things in order to make sure that you're really strong, not pretending to be strong, that you're really strong, so that if you have a mistake, you find it at the right moment, that if there is a problem with a publication, that you issue a correction. If there's a problem with your pre-registration or with your plan, that somebody will help you make this, correct this and make this stronger. So for me, open science is all about power and reliability and overcoming these issues of open science is not about making yourself vulnerable. It's about making yourself much stronger by using the force of the community. You can look at this, perhaps some people make the comparison to Wikipedia, for example. So the only way for you to know how solid something is to be able to see all the process. I am proud of my corrections. I am proud of my mistakes and being able to correct them. I don't see this as being more vulnerable. If you meant something else, then please let me know. But for me, open science is really the shift in the way that I look at things. I feel much stronger now than I ever have before, because I never knew if what I did was solid enough. But now that everything is open and anybody can check me, I feel much better about that. So hopefully,
thanks so much. This is Gabby. Just a quick follow-up question.
Yes.
Well, you didn't misunderstand me. It's completely exactly what I was going to ask. But then, just a quick follow-up question. Do you find promoting open science? Do you see any cultural issue? It seems like I noticed that you have good collaboration with people from Europe, from everywhere, Asia. So do you observe any cultural differences? Is it harder to promote open science in a particular culture, or it doesn't matter?
Yeah, that's a good question. I would say, rather than making this about culture, I don't think it's about culture, but I think it's very much about, so far from what I've experienced personally, it is about seniority. So it's much easier for me to collaborate with early career researchers. There are some seniors in the open science community that are more open, but the biggest pushbacks and the most harsh criticism and direct attacks that I've had were from very senior researchers who have been doing this for a very long time. They consider this to be a power play, as if we're trying to target them, but I think it's very important for me to always, for example, when we do a replication, that the reason why I'm doing a replication is not because I'm trying to attack or bring down this classic article. It's, to me, this is a tribute to something that I find to be impactful, something that I want to build my research on. So I considered replications, or open science in general, reproducibility, as a service to the original authors. So I'm helping them check and make sure that they haven't made mistakes, or helping them check that this is still relevant 40 years later, or helping them check that this is relevant not only for Princeton students, but also for University of Hong Kong. And I'm inviting them on a journey. They can join me and help or not, but I really try to separate specific people from the actual science. And I think it's very important for us to treat it this way. For some reason, the senior folks, or the people who are right now in positions of power, still seem very much against this. Things are shifting. Another problem is also in the current power structures, is that journals, publications, funding agencies also are very old school, definitely so with Hong Kong. So the Hong Kong grants councils, I failed miserably for 4 years to get anything from them that has to do with open science. And the reviews are they're not just like, we don't care. They're just like hostile to the point of me just feeling miserable about it. So I decided to just put this aside and focus on what it is that I can do. Most of our funding, it's ironic, but most of our funding comes from the teaching side, which they're very passionate about what I'm doing with undergraduates. So I didn't really need that much from the research, but it will take some time to shift the publishers and the grants funding authorities and the senior folks. But things are, in psychology at least, management is going to take some time, education is going to take some time, exact sciences, but in psychology, especially social psychology, things are changing super fast. I never imagined that we'll have all these kinds of initiatives. So I'm very optimistic about psychology right now.
Thanks so much. It's very good. I see a couple of questions there. Because of time, I'll stop here and then I'll let you address those. Thanks.
All right. Okay. Jennifer says, when your students are trying to replicate previous research work, have you come across any research results that are not replicable, not because of fraud, but maybe due to poor methods, documentation? If so, what do you do? Any advice on preventing this from happening? I didn't have a chance to go into this in detail. We don't have a lot of time. But if you go to any of the other talks that I gave, right now in psychology, my summary of social psychology is that the replication rates are somewhere between 30 to 50%. So it means that we have 50 to 70% of stuff that does not replicate well. And in the stuff that does replicate, the effect sizes seem to be about half of what has been published. This is not a good place to be, at least in my view. This is not the kind of science that I expected to come into starting a PhD. In the beginning, we thought things are very bad, but the exact sciences, the hard sciences, so-called, reassured us that things are going to be much, much higher in the exact sciences. But after, especially 3 months ago, came out Cancer Biology, where they tried to do their own project. And now we understand that social psychology is actually much higher. So the replication rates are lower than 20%, and real problems with reproducibility because of the amount of money and the complex procedures and all of that. So definitely, even in our projects, we failed to replicate some of the findings. In most of those, we've been able to identify some reasons for why that might happen, but it could also be that some of the published literature is not solid and it needs to be revisited. It's also possible that something has changed after 30, 40 years. If we don't replicate things continuously over time, how do we know when something stopped working or being relevant? There's no real reason to fear that. I think it's very important for us to accept both failure and success. We just, in my courses, I try to tell the students that they're not being evaluated by whether what they ran failed or succeeded, by how solid things are, how transparent they are about everything. And then as a community, we can try and decide which one is the more accurate, or as an aggregate, what does that say about the phenomenon? There are ways to try and address this or increase the chances for success, but that's for another time. I don't think we have enough time to address that, but hopefully that gives you like a teaser of the answer involved. I think are we out of time, or should I take another one?
Let's take another one, the last one from Info, and then, but if anyone needs to leave, just feel free to go. Yeah, thank you. Okay, we take the last question. Thank you.
Okay, so last question. Okay, I understand the question. Okay, so the question is, why is it more popular in psychology but still not popular in business, if I understood correctly? And referring specifically, I think, even to OB. So I think it's a time lag. I think management is behind social psychology in about 5 to 10 years. I think it's just a matter of time till this becomes common practice. Plus, there's some stuff in management, some emphasis in management that is different from psychology. So for example, management really, really cares about the theoretical gap and the theoretical contribution and the theory. So you've got 20 pages of introduction, 2-3 pages of methods, results, and then 20 pages of a discussion. In psychology, it was very much about the evidence. So it's easier to make that shift. Plus, I think it takes time to change the norms. So I think OBHDP is already one of the top journals in experimental organizational behavior is changing. And slowly, I think journals of applied psychology and maybe AMJ, Academy of Management journals will follow. I think it's a matter of time. Already you have editors like in Leadership Quarterly saying things like, we need more register reports, or we need more open data, we need more pre-registrations. The Asian journal, perhaps someone said China themed journal, MOR, does register reports. So things are changing, albeit they're just taking a little bit longer. And I think it's a matter of 2-3 years. By the time that you finish your PhD and get on the job market, I think the field will be ready for you. And open science, it just takes time. Even in psychology, it might have seemed like things are easy. I try to make it seem like it's appealing and easy, but it's not always the case. I've had to struggle for the last 4 years in order to get this team and the kind of impact that we're having in terms of publications. And it's still not easy with the top journals like Psychological Science and JPSP and some of the others. It's an ongoing journey, but within a decade, I have no doubt that things have to change. They cannot remain the way that they are. You need to be patient, and you need to prepare yourself not for what's happening right now, but what's going to happen when you graduate and for when you become a scholar, and to decide what's important for you. Do you want the theory or the way that things are right now in your field, or do you want to make sure that you have solid evidence that people can build on and draw inferences from? So yeah, it's a decision that you need to make. I suggest you make this as early as possible and find others a mentor. So I know, for example, in management at HKUST, there are a few mentors that care about open science, that you choose a mentor that is aligned with your ideals and your view of science. Yeah, all right. I see some other questions, but I think we'll wrap it up for now. If you have any other questions that you want to ask or talk about, you're very welcome to reach out to me and ask me privately afterwards on email. Thanks so much for the opportunity.